Hello everyone, we are going to talk about the Laplace law. So the Laplace law is just for the adiabatic transformations. This is specific just for the case where there is no heat exchange. So basically we have a law that is mostly known by this equation, but also we have these two equations that are related to the first one, and the law is gathering these three equations. So I'm going to show you in this video how to explain how to deduce the two other equations from the first one. So in order to do that, we are going to use the perfect gas law, PV equal to nRT. So we are going to start from the first equation, that one, and we are going to use the perfect gas law as well. So if we replace inside of the first equation the pressure by the expression of the pressure that we can deduce from the perfect gas law, so it's going to be P equal to nRT over V. So I'm going to take the equation 1. So if I replace the pressure that I deduced from the perfect gas law inside of my equation 1 of the Laplace law, then I will obtain this result. Okay, so now what I can do is I'm going to gather the powers of the V, because as you know, I'm going to make a small reminder about that, about a mathematical law that I'm going to use. So when you have 1 over A, for example, in mathematics, it means that this is A power minus 1. So if I have 1 over V here, it means that it's also V power minus 1. So at the end of the day, I have V power gamma, and also I have V power minus 1. So I can gather both together, and I will have V power gamma minus 1. So this is what I'm going to write here. Equal to constant 1. And now what I'm going to do is to bring all the constants that I have in the other side. So n is a constant, r is a constant, T is not a constant, T is the temperature, and the volume is not a constant neither. So the constants that I have in these equations are these two quantities that I'm going to bring in the other side. So I'm going to have that equation. Now that I can see what I have in the right side of the equation, everything is constant. Constant 1 is obviously constant. N and R are constant, as we said. So the whole ratio here is going to be called constant 2. And then what I will have at the end is T times V power gamma minus 1 is equal to constant 2. And this is exactly the formula that we had above in the beginning of the video when I was explaining the law here that you are interested in. Okay. So now we are going to prove the other equation that we had for the law. So it's going to be exactly the same process, but this time instead of replacing the pressure, we will replace the volume. Okay, so this is again the equation 1 of the first. The first equations of the law that we had, the Laplace law. So now I'm also going to use the perfect gas law here. and this time I'm going to express V in terms of the other parameters. And I'm going to replace this inside of the equation 1. So I will have P times nRT over P equal to n to constant 1. Perfect. Okay, so we have P over nRT equal to constant 1. But here there is something that we need to add, because I replaced the V, but the V is with the power gamma. So this whole thing here is with the power gamma, because it's actually the V that we replaced. Okay, so now if I come back to the equation, so I'm going to have P times n power gamma, r power gamma, t power gamma, and P power minus gamma again. So this is exactly the same process than the one that we did for the volume earlier. So basically 1 over P is like having P power gamma is like having P power minus gamma, and this is equal to constant 1. So I'm going to gather the powers of the pressure P together. And now, exactly like I did earlier, I am going to identify the constant and bring them in the other side. So n is a constant, r is a constant. So I am able to take them and bring them in the other sides. Okay, this is a gamma. So if we look at this equation, once again, the right side of the equation is a constant that we will call constant 3 here. Because as we said, n is a constant, r is a constant, gamma is constant, and everything here is constant. So finally, it's a new one that we call constant 3 that is involved here. And finally, we have the equation that we were talking about in the beginning. So that was the demonstration of it. So that was the demonstration of the two other equations of the Laplace law, because the first one is P V power gamma, that is very known, and the two others are deduced from the first one, but they are also the Laplace law.